Good evening students. Now I am going to present the topic as rotational kinetic energy. Uh, so we are considering the rigid body. Rigid body is rotating about an axis x dash with constant angular velocity omega. First of all, we should know the rigid body. What is rigid body? We know very well rigid body is an object which has definite shape and size, but it does not change due to external force. In other words, we can say easily rigid body is defined as an extended object in which distance between the particles is not altered during the motion. So rigid body is an object has definite shape and size which cannot change until the external forces act on it. So now we are considering one rigid body. The rigid body is rotating with respect to an axis x dash. If it is in rotational motion, means that it has angular velocity which is represented by the symbol as omega, and all the particles in the rigid body have same angular velocity omega but different linear velocity v. So v1 v2 v0, not only each system have only one particle, there are many number of particles are there. So we have considered the linear velocity of the particles v1 v2 up to vi, and masses of the particle is m1 m2 up to mi, and the distance about the rotation is r1 r2 up to ri. We know very well kinetic energy of the kinetic energy formula is, general formula is half mv square, but here kinetic energy of the particle with mass m1, so you have to write 1 by 2 m1 v1 square, mass m2 we have to write 1 by 2 m2 v2 square. We need to find the total kinetic energy of rigid body, so we are considering adding all the particles energy. Total kinetic energy is first particle kinetic energy 1 by 2 m1 v1 square, second particle kinetic energy is 1 by 2 m2 plus 1 by 2 m2 v2 square, and we don't know how much amount of particles in each system, so we are considering ith particle. So ith particle kinetic energy is 1 by 2 mi vi square. We know very well the relation between linear velocity and angular velocity formula is v equal to r omega. So first particle is v1 r1 omega, and second particle is we have to write v2 r2 omega, and third particle is we have to write vi is equal to ri omega. So adding this, v1 can be replaced to v1 square can be replaced to r1 omega r1 square omega square, plus v2 square can be replaced to r2 square omega square, and vi square can be replaced to ri square omega square. So total kinetic energy of the system is kinetic energy is 1 by 2. The common term is 1 by 2 omega square is common term. Remaining answer is m1 r1 square plus m2 r2 square plus m3 r square. So generally we have to write summation over I mi ri square. So the mi ri square is moment of inertia I. So total kinetic energy of the rigid body is 1 by 2 I omega square, where I is moment of inertia of the rigid body. So moment of inertia I equal to summation over I mi into ri square. That is, we know very well moment of inertia is defined as the product of the mass and square of the distance between the two particles. So this is the 1 by 2 I omega square as the rotational kinetic energy.